Okay, problem number 17. Use analytic methods to find the local extrema in the intervals of the function of increasing and decreasing. Well, let's start with asking the question, is there any restrictions on this domain?
Yeah.
Zero.
Zero is not in the domain. Okay, so the domain consists of all numbers except 0. Right?
Yep. Yeah.
Okay,
Yeah.
so there you got that. Now, what effect does that have on things? If I remember correctly, and then this is not getting to the part where I use derivatives, if I remember correctly, this curve looks something like this.
Yes.
Indeed, we do.
It's a hyperbola.
Something like that.
All right? Okay, so if that's the case, I mean, just from looking at the graph, I'm going to say, golly, it looks like the whole thing is decreasing.
You actually say golly?
I did say golly.
Wow. Golly.
Well, let's see if that's confirmed by taking the derivative. Okay, 2 times, this is 2 to the negative x to the negative 1. So 2 times negative 1 times x to the negative 2, or it's negative 2 over x squared. Now, last time I checked, x squared is always positive for the real numbers. So negative 2 over x squared must always be negative. So our conclusion, by basically looking at the graph and by looking at this, is that h of x decreases on its entire domain. Is a decreasing function from negative infinity to 0, and also from 0 to positive infinity. Are there any local extremes?
No.
Certainly not absolute. There's no absolute minimum because this thing keeps on going down. Certainly no absolute maximum because that thing keeps on coming up. And this function approaches but never gets to 0. It approaches 0 here. It has asymptotic behavior there. It approaches 0 over here. It has asymptotic, but it never reaches 0.
Isn't it like 0.999 repeating forever?
I thought we already had that discussion.
Yeah, but isn't it like that?
The answer is no. Because no matter how close to 0 you want to get, I can get closer. Okay, so decreasing everywhere, no local extrema, and there's no place where it's increasing. Are we good? Excellent. Number 17, done.
Yay.